So, welcome back to CoffeeShop Astrophysics. As always, if you have any ideas for a future talk, feel free to come up to us after the presentation, or you can reach out to us on our website linked below. Thank you, Tom. That might be a problem. So, if you happen to be in the Madison area on December 17th, our friends at UW-Madison's Astronomy on Tap will be giving a talk at Working Draft Beer that I'm sure will be excellent. And we are CoffeeShop Astrophysics. We are a group of graduate students and postdocs at the Leonard E. Parker Center for Gravitation, Cosmology, and Astrophysics at the University of Wisconsin-Milwaukee. Your speakers today are myself, Ronan Humphrey. After me will be Amanda Baylor, and following her will be Gabe Friedman. And if we haven't said it enough this year, CoffeeShop Astrophysics is 10 years old, which is very impressive, thank you, for a completely student-run organization. We've given 79 talks, and in those 79 previous talks, we have covered dark matter and dark energy. We've talked extensively about gravitational waves, and we've even covered exoplanets and astrobiology. But today, we're going to finally give the people what they want, and we're going to talk about aliens. All right. So why the hesitation? Firstly, aliens are, of course, controversial. That's why there's so many people here. There is some element to belief in aliens, which makes it a little bit difficult to talk about scientifically. You will have people on this end of the spectrum who believe that Earth is completely unique, there is no other life in the universe, and that we're all alone. You may have a few more people who are a little further towards this green area of the spectrum who think that there's probably other kinds of life. Maybe this is like a slime mold here on Earth. That might be unrecognizable to us, but is life. And then you'll have some people here who think that, well, some of those videos are interesting, and there might be something more out there that might be more intelligent or more like us. And then there are people all the way here who are certain there are aliens, they have been to Earth, they have made contact with us. So, reaching this full audience is a bit difficult in one presentation. Another problem is that researching this topic has its difficulties. There are innumerable hoaxes, conspiracy theories. Hoaxes, for example, like this 1990 hoax taken by Patrick Maréchal in Belgium during the Belgium UAP wave. This is a piece of styrofoam with flashlights in it. This stood for 20 years before it was debunked by the photographer himself. Then we have conspiracy theories like the Men in Black or Area 51. There's tons and tons of disinformation, misinformation, and pseudoscience, like the Alien Autopsy film, which was a film released in 1995, which was purported to be found footage from a 1947 crash in New Mexico. Oop, that's the wrong way. So, thirdly, as I sort of hinted at, there is a lot of sketchy stuff around talking about aliens. There's lots of government and military involvement with cover-ups and secrets and classified projects that we just don't know how to talk about easily. And then lastly, public perception. Scientists want the public to trust us and to think of us as authority figures. This is difficult if we associate ourselves with things like the Heaven's Gate cult or tinfoil hat conspiracy theorists or this guy from the History Channel. So what do scientists think of aliens? This may be a bit of a surprise to you, but scientists are also people. So we fall on the exact same spectrum. You will have scientists who think that we're completely unique and that the chances of alien life is vanishingly small and we shouldn't even be looking. And then you'll have scientists who are curious, who want to know more, who are searching actively to find these aliens. And then you probably have a few scientists who have made contact with aliens and will tell you all about it. So I'm going to categorize these three people for the purposes of this talk. We'll say the skeptic is in this side, and we'll say the slime mold people are there too. And then the dreamer, these are people searching for aliens, but they're not convinced. And then there are certainly believers. So I'll start with the skeptic's view. And I'll start by telling you a story. So this is a very famous story in physics and in science in general that occurred in 1950s. Probably the summer of 1950, Dr. Enrico Fermi, pictured here on the far left. If you saw Oppenheimer, his name may be familiar to you. He was visiting Los Alamos National Lab and was having a lunchtime talk with three other scientists, Emil Konopinski, Edward Teller, and Herbert York. And they were talking about some silly things, perhaps interstellar travel. And this comic in The New Yorker came up, where the comic artist was proposing that a recent phenomenon of missing trash cans in New York could be explained by another recent phenomenon of flying saucer sightings. So Fermi thought this was a great idea because it explains two phenomena with one explanation. And they went on to discuss other things, more real-life things, the weather or their work, when there was a lull in the conversation, and Fermi said, sort of to himself, but sort of to everybody else, "Where is everybody?" And he's not worried about who else is there at lunch. What he's thinking about is that the universe is massive. It is so huge. Massive might be the wrong word, but it's also that. The observable universe is currently, because it is growing, 93 billion light years in diameter, so from one end to the other. And that gives us a volume of over 10 to the 70 cubic miles. So that's a 1 with 70 zeros after it. That's a lot of space. You could fit a lot of stuff in there. So this gives the idea that we can't be the only intelligent life in all this space. And that brings us an aside to Fermi problems. So Fermi loved to do these kind of problems where you make estimations to find answers to questions that you can't possibly know the answer to, like how many cups of water are in Lake Michigan. So if I wanted to solve that, and you can do this at home, you know about how large a cup of water is, you can look up various measurements of how deep and how large Lake Michigan is. You can do some math to figure out about how many cups are in it. You won't be right, but you might have a good estimation. Another similar one, if we put every person within the city limits of Milwaukee, how crowded would it be? We know the population is about 8 billion people. You can look up the city borders for Milwaukee, calculate the area, do some math. And then one of my personal favorites, how hard would you have to slap a chicken breast to cook it? And I'll let you figure out how to solve that at home. So this new Fermi problem that Fermi invented right then was, what is the probability that we will be contacted by aliens within the next 10 years? And this was a really important question. This is actually a 1985 report published through Los Alamos by Eric Jones, and it includes accounts from Konopinski, York, and Teller all about this conversation. This is sort of like the apple falling on Newton, but for aliens. And this also becomes the Fermi paradox. So from the calculations that he did there at lunch, again, this sort of back of the envelope, out loud, quick calculations, quick estimates, he thought that other intelligent life would be highly probable. And so since we haven't been contacted, allegedly, he proposed 3 reasons that might be. The first is that interstellar travel, that is travel between 2 star systems, so like our sun and another star, may be just impossible. And so we'll never see anybody else. Or that stellar travel is possible, but not worth the effort. So perhaps other aliens can do it, but they don't want to. It's not fun for them. And then finally, that technological civilizations may not last long enough for it to happen. We certainly haven't figured out how to do it yet. Who says that someone else has? Another problem is that the universe might actually be too big. So if we look to our next closest galaxy, it's Andromeda. So this is us on the Milky Way. We can't see this. This is an artist's interpretation. We're in it, so we just get that edge-on view that you've probably seen if you've ever been to some dark sky places. But we're located down here, kind of in the middle of nowhere. And if we want to go to another galaxy, it is 2.5 million light years away. So for us to send a signal out there in the form of light, it would take 2.5 million light years to get there. And similarly, if they look back at us, they're going to see the light that we put off 2.5 million years ago, when we looked like this. This is your ancestor, Australopithecus. Say hello. So when we're thinking about contacting other intelligent life, we really need to look locally at the Milky Way, and we're not looking at the whole universe. But luckily, there's still a lot of stuff in the Milky Way. So that brings us to the Drake equation. Sorry, not that one. So this was an equation that Frank Drake, pictured here on the right, came up with in the early 1960s when he started being really interested in finding other alien intelligent life. So he was going to host a meeting about this. And so he wanted to think about how we talk about how hard this is going to be. We want to know what the challenge is before we take on a project. So he was thinking about everything that's needed for life and everything we would need to contact that life or for them to contact us. And he was realizing that if he put all of those sort of numbers or factors together and just multiplied them through, we would get a number n that would be the number of detectable civilizations in our galaxy. So I'll show you that. It looks scary, but it's just multiplication. So again, this number n on the left here is the number of alien civilizations that we can communicate with. So send a signal, and they send a signal back. It is given by all of these numbers. The first is the average star formation rate in the Milky Way. We are able to measure this through a number of ways, and we think we have a pretty good idea of what this number is. And then we have the fraction of stars with planets. This is something we're still working on. You may have heard about the exoplanet boom that we're sort of in the tail end of. We're a lot better at finding exoplanets than we used to be, which gives us a better idea of this number, but more work still needs to be done. And then we have the average number of life-supporting planets per star. This is a little harder because we don't necessarily know what's required for life. We know what's required for us to live, but we might not be the only shape that life takes. So this number's a little hard to find. And then we get into the fraction of those livable planets that then do develop life, and then the fraction of those planets that do develop life that then develop intelligence or a civilization. Thank you, Tom. And then we have the fraction of those civilizations that develop technology that's able to be sent out into space, like we've done. And then finally, the length of time to develop that technology. And I've colored these all red because we have no way of finding out what these are. We have a sample size of 1, very difficult to get good statistics on these. Tom, could you? Thank you. Perfect. Another note is that the Milky Way may also be too big. So our nearest neighboring star is Proxima Centauri, and it even has a few planets. It's only 4.25 light years away, which sounds a lot better than 2.5 million, but that is still 5.88 trillion miles. We don't have the technology to travel that distance, and we probably won't in the near future. So if there are aliens, they're gonna have to come to us. And this leads us sort of to the rare earth hypothesis, which is what I'm going to leave you with for the skeptic section. And this hypothesis proposes that the requirements for intelligent life to send a signal into space are extremely improbable. So I'll list some of those requirements as we think they currently are based on us. So you start with a star with a rocky body orbiting it. So you could have a star and a planet, or perhaps a star and a larger planet and the moon is a rocky body, but we need something that you can stand on. That star needs to be in the galactic habitable zone. So I showed a galaxy. You see there's a lot of stuff in the center. That's too busy. That has too much energy, too much heat, too many supernovae and cosmic rays going off. It'll just wipe out life. So you need to be in a sort of quiet area, but not too quiet that it's cold. And we think that you need these sort of gas giant guardians like we have here. So one of the reasons that Earth does not get constantly pelted with asteroids is that Jupiter, Saturn, Uranus, and Neptune are so massive that their gravity pulls away a lot of that sort of space junk that could hit us and wipe out life. And then that rocky body itself, so where let's say the planet for these purposes, the planet that goes on to develop life needs to have lots of things. It needs to be in the stellar habitable zone. So it needs to be not too close to the star that it's too hot for life and not too far that it's too cold. It needs to be in a stable orbit. You want similar temperatures all year. We want a magnetic field to protect us from charged particles coming off of the star. And we need an atmosphere, and we need to keep that atmosphere. If we look at other planets, especially other rocky bodies, in our solar system, we see that they used to have an atmosphere, but they've lost it, or they're currently in the process of losing it. We need certain elements like carbon and oxygen, and we think this because that's what we're made of, and that's what we need for life. And then we also think even details like plate tectonics. Earth seems to be pretty unique among the rocky planets for having plate tectonics. And geologists and biologists think that that's important for moving temperature and energy around the planet as it cools. And then that planet, of course, needs to actually develop life. It needs to evolve and develop technology, and this turns into a biology talk that we're not qualified to give. So this is all to say that we might be completely unique, and even if we're not, we may not be close enough to reach anybody like us. So sorry to start on a downer, but I'll turn it over to Amanda, who will hopefully give you some hope.
Okay, can everybody hear me? Okay, fantastic. So I'm going to call myself the dreamer. I'm a little less skeptical than Ronan, and there's some things that make me wonder, what if, and what about this thing that I've seen that might make me believe that there are aliens out there? So I'm going to start by saying we are not unique, and this principle came around during the Copernican revolution. I have Nicholas Copernicus pictured here on the left, And he proposed this idea of a heliocentric universe. And before this, people thought Earth was really special. They thought it was the center of the solar system, but they also thought it was the center of the universe and that it didn't move and that it was fixed, and that all other heavenly bodies moved around it. Now, we know this isn't true, and Copernicus said, well, the sun is at the center, and actually we're moving around it. So it made people start to wonder, oh, maybe, we're not the center of the solar system. We might not be the center of the universe after all, and we might not be as special as we thought. So then along comes this guy, Giordano Bruno, and he was an Italian philosopher, and he proposed this idea of the plurality of worlds, which means that there are many, many worlds like Earth or similar that could exist in the universe because the universe may be infinite, actually, in expanse and populated with many worlds. So he said that other worlds, in this quote, have no less virtue nor a nature different from that of our Earth, and like Earth could contain animals and inhabitants. We don't know necessarily what they look like, but he proposed this idea that they could exist. Now, of course, the church was not happy with that because the church thought at the time that we were really special and persecuted anybody that went against that notion. So they burned him at the stake by the Venetian Holy Inquisition. But he ended up becoming a sort of martyr for science and a symbol for free speech and free thought. So then after that, we have the Martian canals. After the invention of telescopes, this guy named Giovanni Schiaparelli, in 1877, he was an Italian astronomer, and he started drawing these really meticulous maps of Mars. He would look through his telescope and observe the planet night after night and just draw what he saw. And what he saw was these sort of, what he saw was these like sea-like structures, but then canals connecting them. And he called them canali, which actually means channels in Italian, but was mistranslated in English as canals. So it made people start to think, oh, are these being built on Mars, or are they naturally occurring? Is there water on Mars? People started to get more curious. So along comes Percival Lowell, and you might remember Percival Lowell from our Pluto talk because he built the observatory that discovered Pluto. And he spent most of his time looking for Pluto, but in his free time, he looked at Mars a lot. And he himself also drew really detailed maps. Here's him sitting in his telescope. It's a 24-inch refracting telescope at the Lowell Observatory. You can actually go see it. He had this chair specially built so he could sit there all day and night, move up and down and around the dome, and he would observe Mars. He published 3 books on Mars and its canals, but the difference was that he actually believed the canals were built by intelligent civilizations for irrigation purposes. Maybe they had farms up there, who knows? But this is one of the drawings that he did. And then they also published this in the newspaper, sensationalized it. People started to think there were things on Mars. And you can see this is kind of ancient aliens-esque newspaper with a refracting telescope pictured here, and the observatory, and Lowell himself with all of his drawings of Mars and its canals. So you can imagine the aliens are up there, they have their little UFO dozers, they're building these canals. For what? We don't exactly know, but they might be up there. So then this inspired H.G. Wells, who wrote The War of the Worlds in 1898, just a couple years after Lowell started publishing his books. And in this story, the Martians come down from Mars because they've harvested all of their natural resources on their planet, and they have to come down and wipe us out so that they can steal our resources. So you can see the Martian pictured here. These are actually original illustrations from the original publication in Pearson's magazine. It wasn't published as a book. It was actually published in segments in the magazine. And he described the aliens as having these giant bulbous heads and eyes and these large tentacles. So you can see the actual Martian labeled here. And then they came down in these tripod-like structures, which kind of look like UFOs, although UFOs weren't really around at that time. So later, there was a radio broadcast by Orson Welles based on this novel, which incited panic of a Martian invasion. He was on it was called the Mercury Theater on Air, and he did this radio broadcast where he said Martians were invading. It was a Halloween episode. It was meant to just retell the story of H.G. Wells, but people thought Martians were actually invading, and they got panicked. So Orson Welles had to issue a public apology after that, saying, I'm sorry, Martians didn't actually invade. But you can imagine if you're flipping through radio stations and you hear Martians are killing everybody and you don't have access to Google to see if that's true or not, then, you might be really worried. So this sort of paved the way, though, for, aliens in science fiction, and to be like, Martians will come down and wipe us out, or maybe they're friendly, maybe they're not. They always want to steal our resources or kill us. But I have some bad news. So in 1964, they launched the Mariner 4 probe, and this was meant to do a close flyby of Mars. So you can see the probe pictured in the top right corner, and it took really nice high-resolution close-up pictures of Mars. And here's one of them, as you can see. Oh, sorry. There's one of them that you can see on the right-hand side. And they found that there were no canals in any of its images. So a little disappointing, but they did find that there was a lot of craters. They concluded that Mars has a thin atmosphere because it's getting bombarded by so much stuff, whereas our atmosphere sort of takes care of us and protects us from those things. So they concluded that Mars is not a good place for life, although they didn't rule out the possibility that life could exist on Mars. It just might exist in smaller forms, not something big enough to build a canal. So I need to digress for a second and talk about the importance of radio astronomy in the search for intelligent life. So all natural objects emit radio waves. I emit radio waves, you emit radio waves, everything does. And these radio waves can travel long distances in space, and they're not blocked by gas or dust, making them really good for us to send signals out into space so that someone might hear them, or for us to receive signals from very distant stars, galaxies, whatever, planets. And we use these large radio dishes to detect them. You can see one pictured here. So light comes in from a distant radio source, it goes into the dish and gets reflected into a secondary reflector, which then feeds it back into the processing control room, and we get to process these signals. The radio is on the long wavelength end of the spectrum over here. And you might have seen pictures of like arrays of radio telescopes. So why do we build a bunch of these things? Well, it's because it's hard to build one giant dish, so we just build a lot of smaller ones in a greater area. And then it's important to note that TV and radio broadcasts can also travel into space. So anything we watch on TV, aliens could be seeing that out in space right now. So this is what inspired Carl Sagan's novel Contact. And Carl Sagan, we've heard his name mentioned earlier. He is a very famous astronomer and scientist, and he wrote this science fiction novel called Contact in 1985. So astronomers were working on radio telescopes in New Mexico, and they receive a signal from the Vega system, which is about 26 light years away. So not crazy far away. And they decoded the signal and found that it's a retransmission of Adolf Hitler's opening speech at the 1936 Summer Olympics in Berlin. So Sagan hypothesized that this might be the first major television signal enough to escape Earth and its atmosphere, because this was the first time that the Olympic Games had been broadcast live. So it's kind of scary to think that the aliens' first hello would be a speech of Adolf Hitler at the Olympics. But the aliens continue sending signals, which they then attempt to decode. And I'm not going to spoil this novel because I think everybody should read it. It is a fantastic piece of science fiction that you should read. But it sort of makes us think about the signals that we're sending and receiving from aliens. Okay, now if you asked me to draw an alien, what would I draw? I'd probably start with a bulbous head. I'd probably paint him green. Why not? A little body, probably not as tall as a human, but you know, maybe a good size. And I'd probably draw these like weird little tentacle, proby fingers. And I'd give him, you know, big glowing eyes. I also put on a mouth so he can talk to me. And then for fun, I might just throw on some antenna. And this might be your stereotypical idea of an alien. I mean, it looks like the emoji, the alien emoji. It's our idea of these things with big bulbous heads and big eyes. But why do we actually think aliens look like this? Where did this stereotype come from? Well, I'm going to tell you. It's the little green men stereotype. So back in 1936, this guy wrote this novel. This sort of started in science fiction, where people started painting aliens green in their stories. This is just the earliest account that I could find, which actually had an illustration with it and a quote, little green man. So in 1936, this guy, J. Harvey Haggard, published this story of an astronaut going to Venus and harvesting crystals, and they encountered these aliens, and he refers to one of them as a little green man. So it's the first time it's like published in fiction. And then, later, in 1955, we start having these close encounters of aliens where people are actually seeing them and claiming that they've seen a little green man standing in front of them. Most famously is the Kelly Hopkinsville encounter. So back in rural Kentucky, this family on their farm had encountered aliens late at night. And this is so famous because there were so many witnesses to this story. It's extremely well documented. But the only evidence they could find was the gun shells, or the shotgun shells of the family, because they had, well, you know, if you encounter an alien for the first time, obviously you're just going to get your gun and shoot at it. So they thought they were hostile. They tried to kill the aliens, but they said they were impervious to bullets. So the police found no evidence of any little men running around, but they found the shell casings. So this is how they describe them, as little silver people. or things running around in the forest. And people think now they're great horned owls because they sort of fit the description. Also, great horned owls are known to be territorial at night, so they will attack you. And this is what people think now. But the papers at the time actually published that they were little green men. So the media sort of sensationalized this and lied about the color of the aliens and called them green instead. Then later, in 1967, we have astronomy, an astronomy occurrence of this, where Jocelyn Bell Burnell finds the first pulsar. And a pulsar is a star that rotates and puts off this signal. We've talked about these 100 times in our coffee shop talks, but they put off this signal that kind of looks like a lighthouse. So every time you see it, it comes back around with a very regular interval. So she saw this really repetitive signal and thought, oh, this might be intelligent life. And this was in the radio, I should mention. And she names it Little Green Men 1, or LGM-1. Just kind of jokingly, but later they found that this was actually a star. And then later, even today, we have in toys and games occurrences, we have LGM in Pokemon Generation 5. He looks like a little alien, and it's LGM for the acronym LGM. So that sort of paints a picture of what we think aliens look like in our head, but also what contributed to this was the Barney and Betty Hill abduction. So now we have alien abductions starting to happen. In 1961, in September, this couple, Barney and Betty Hill, pictured here, are driving home from vacation with their sweet wiener dog, Delzy, pictured here. Delzy had no account of this, by the way. She's a dog. So they observed these human-like aliens who came down in a UFO. So Barney had drawn this picture of this UFO, and they saw the aliens staring at them from the windows of the UFO. And they don't really know what happened after that, after they encountered the aliens. They lost memory. Somehow they got home, but they got home 3 hours after they were supposed to arrive, so they don't really know what happened in that time period. And they noticed weird things after returning home, like their clothes had been messed with and torn, and that maybe their luggage was missing. They were just really confused. And this was sort of influential in shaping our ideas of UFOs. As you can see here, the flat disk sort of shape that we see for UFOs. And aliens, this is based on the description that Betty gave. They had big bulbous heads, big eyes, and they, for some reason, were also wearing hats and leather jackets, but that's besides the point. So now we think about aliens in a new way, and this paved the way for future abduction stories to happen. So we need to consider, are aliens our friends or are they our enemies? And we see this a lot in the media. We see E.T., who's the friendly alien or friendly extraterrestrial. We also see the alien life form Alf, who is a friendly alien, but he might eat your cat. And also we see the little green men from Toy Story, who are just obsessed with the claw machine and don't really have any malicious intent. Then we also see descriptions of aliens where they are maybe more hostile, like in Destroy All Humans, where you can play as Cryptosporidium, the little stereotypical gray alien, although in the video game, people will yell at you that you're a little green man. And the whole point of this game is to harvest the human's brains. And then you see, the xenomorphs in Alien, who are very hostile towards us. And then also Mars Attacks, a classic film where the aliens just kill you with their ray gun. So we need to consider, when contacting aliens, is it such a good idea? Well, I'm going to let Gabe tell you more about that. Thank you.
All right, how are we on sound? Everyone able to hear me okay? Perfect. So for this final section, I come in peace. And I come to you from the final part, not the skeptic, not the dreamer, but as somebody who just has to know that aliens are out there, they're somewhere in our universe, and perhaps they've even come and visited us on Earth before. I come to you from the perspective of the believer. Now, to start off this section, if we're going to be talking about aliens from like the belief perspective that they were here, there is one particular object that is synonymous with alien encounters, and those are UFOs. Probably all heard of UFOs, and we're going to start off this section with a nice little game that I like to call UFO or No. I'm going to show you 7 pictures of seven purported pictures of UFOs, and we're going to try and figure out which one of these are real and which ones are not. So here are your 7 photos. Now, we'll start with the one in the top left. Do we think that this might be a picture of a UFO or just maybe some plane or some other object? Well, you might be surprised that that's a picture of a UFO, and that the second one's a picture of a UFO. And if we keep going on, every single one of the pictures that I have up here is a UFO. And before everybody starts panicking, freaking out, thinking, oh my goodness, I've been lied to my whole life, or oh my goodness, I've been right my whole life, what I need to make sure we all understand is what a UFO actually stands for. UFO stands for unidentified flying object. And so while, yes, it's usually meant to mean some kind of extraterrestrial vehicle or alien spacecraft, strictly speaking, a UFO can apply to almost anything that you see in the sky, but you just, at the moment, can't really identify it. You can't explain what it is. Now, I will say that while UFO is the operative term, or has been for quite some time, the government organizations are now kind of formally calling them something different to reflect this distinction from aliens and just unidentified aerial phenomenon, to which I understand, but I say boo anyways. So you can just, for example, take these two photos here, traditional drawing of like an alien spacecraft. That's a UFO as far as we all know. But the thing over on the right, if any of you were even able to tell that that's a plane, that's just a blurry photo of a plane. If you saw that, it's in the air, it's flying, can't identify it, that is technically a UFO. Point being though, if you see something like this, you can't just assume that it's an alien spacecraft because strictly speaking, a lack of data does not make aliens the likely answer. And that is important as we go into this next section of the talk where I give sort of a brief history of UFO sightings over maybe the last century or so. We're going to start first in the world wars, particularly World War II. It should come as no surprise that as humans invented planes and the capability of flight and then started using them for military purposes, and other countries are developing planes and using them for flight, and now we're fighting each other in the air, that there's going to be an increase of encounters of objects in the airspace that we just can't identify in the moment. In particular, what I want to focus on are these things, these little like glowing fiery balls of light that some Allied Air Force pilots reported sightings of during World War II, and it actually wasn't just the Allied forces that saw this. There were similar reports from German and Japanese pilots. These would be like small lights that seemingly followed the planes around. They would zoom off in other directions and then just disappear. Now, this is expected to be some sort of like electromagnetic phenomenon in the atmosphere, things that they, again, didn't fully understand at the time because we had just been developing flight capabilities, but at the time, they had no idea what it was, and they gave them a particular name. That name was the Foo Fighters. From an old Smokey Stover cartoon is where they got the word Foo Fighters from, and that is, yes, where the band Foo Fighters got their name from. So that happened in World War II. World War II ends. We're in the late 40s now, and a private pilot, Kenneth Arnold, saw similar lights as he's flying around upstate Washington. And this particular sighting, now that we're at sort of the dawn of the Cold War, sparked this mania of flying saucer encounters, which brings us to one very fateful day in the summer of 1947, just outside the town of Roswell, New Mexico, which you may be familiar with. What happened here is June of 1947. There, right outside of Roswell, there's a rancher, New Mexico rancher. He's just walking around his fields, and he starts to see some debris that's lying on the ground, stuff like tape, tinfoil, rubber, wooden debris, scattered at different points across his ranch. And picks it up, thinks, what in the world is going on here? Takes this debris, goes and drives it to a relative of his that lives in one of the nearby towns near his ranch, says, hey, what's going on here? This is at the height of the flying saucer mania, where there are organizations that are actually offering cash rewards if you bring proof of flying saucers. So his relative saying, hey, I think you might got something here. You should see if you can go report it, go down to Roswell, give it to the sheriff, maybe we'll be able to get some money for it. Takes it down to Roswell, reports his findings, say, I think I found a flying disc or like debris from a flying disc on my property. Military confiscates the debris, and then on July 8th, they make the report that they have recovered a flying saucer. And that kind of, that gets printed in the newspaper, that goes out all over the place, and people start to say, wow, that's crazy, oh my gosh, we actually found one. Well, it wasn't a flying saucer. It was just a day later that then, after sort of this hype was out, the military identified that those materials were pieces of a weather balloon. They didn't admit that it was one of their weather balloons they were doing tests on. They just said it was a weather balloon. And that was kind of that at the time. And then a couple decades later, in the late 70s, is when we really started to get into the bulk of the conspiracy theories, UFO conspiracy theories surrounding Roswell, when Stanton Friedman, no relation, interviewed one of the military officers who was present at Roswell, who told Friedman at that particular interview that he believed the debris he recovered was extraterrestrial. And this started a whole new wave of a bunch of conspiracy theories surrounding Roswell, that the government was hiding alien tech, that they were potentially even hiding recovered alien bodies. This just got completely out of control at that point, and we really haven't been able to put the cat back in the bag since. That includes stuff like books, the Roswell incident. We have a documentary that has not a sensationalized title at all. UFOs Are Real. That's the name of it. And of course, was also getting reported in tabloid magazines like the National Enquirer. So that's the Roswell incident. Of course, there have been purported UFO encounters since Roswell. That includes one that I'd like to highlight here, the Phoenix Lights. This happened in the late 90s, in 1997, where for 3 hours across Arizona and also southern Nevada, the residents of the towns and cities around there reported seeing this weird triangular formation of lights that was either passing over their cities or potentially even over Phoenix. The lights appeared to be stationary to some people. They couldn't explain it. Of course, a lack of data does not mean that it's aliens, but a lot of people thought that anyways. What they really ended up being attributed to was just a pilot training program by the Air National Guard that was stationed down in Tucson, Arizona. However, the newspapers, for example, you take a look at this drawing here, that does not look like a pilot training program, but you have to notice the caption in the newspaper that printed this, that people saw something like this V-shaped object. So always read the fine print. Now, we can go to UFO sightings that are potentially more recent, or UAP sightings if I want to be quite literally politically correct here. This is a photo or a video from 2015, 30-second video that was first released by the New York Times and the Washington Post back in about 2017, more videos in 2019, and then the Pentagon officially released these videos in 2020. This is a video from a US Navy fighter jet. Again, they're taking this video, they don't know what the object is, it's flying at very high speeds, it's kind of unusually shaped, doesn't really look like a plane at all, and they really don't know what it is. And there's 2 other videos that are similar to this where, again, they really didn't know what it is, and the US Office Director of National Intelligence also came out and said, like, these videos are real, we really don't know what they are. But the point is again, a lack of data does not necessarily mean that this is alien spacecraft or anything. It could be a drone or some other type of aerial material or aerial phenomenon that, again, they just can't explain. So good not to jump to like too crazy conclusions there. However, if you want to, or if you keep on asking questions like some of us might want to, unfortunately, this is the response that you're probably going to get. So I say, forget them, let's just ask the scientists instead. What are the scientists doing to search for extraterrestrial intelligence and alien life out in the universe? And that falls under the purview of what is called SETI. So SETI stands for the Search for Extraterrestrial Intelligence. It's not necessarily one group, one collaboration. It's a term to describe all global scientific efforts towards the search for intelligent life in our universe. The first modern SETI experiment was performed back in 1960 at the Green Bank Telescope in West Virginia. It was performed by Frank Drake, who you heard about earlier on in the talk. The experiment was called Project Ozma, after the Queen of Oz, from the books at the time. And the particular experiment found nothing of interest. I mean, if it did find something of interest, I'm sure you would have all known about that before coming today, because that would have been a very big deal back in the 60s. 1 year later, there was a meeting at the Green Bank Telescope with not just Drake, but also Carl Sagan, some other Nobel laureates and prominent physicists and astronomers of the time, that really marks the first official SETI conference to organize efforts towards a more coherent set of searches and procedures to look for extraterrestrial life. This plaque that is down here in the bottom right, that's at Green Bank. You can see that's the Drake equation. And then this photo over here is from the 25th anniversary of Project Ozma. Drake is second from the right. The SETI Institute is sort of where a lot of these efforts are consolidated today. So the SETI Institute was founded in 1984. It is a purely non-for-profit organization to further the efforts to search for extraterrestrial life and to understand life in the universe. The primary research center of the SETI Institute is called the Carl Sagan Center, where they do a lot of research in astronomy, astrobiology, geoscience, and other research there under many different projects using many different telescopes across the world and in space. One other key goal of the SETI Institute is to make sure that information that they discover, as they discover it, can be public and that they can help inform the public to make sure that everybody knows what's going on. And that includes radio shows, they have wonderful podcasts, they have a great talk series on YouTube that I believe they update once a month. SETI Talks is what it's called, so you can either search that on YouTube or scan this QR code here. As I mentioned, SETI is a worldwide effort. And it incorporates, there are many different, mostly radio telescopes, but some optical telescopes across the world that do various, or just devote some of their observational time towards furthering the search for extraterrestrial life. There's one that I want to focus on in particular, and it is this one right here. And that is because if you were around back in the late 70s, you may have heard that that telescope actually discovered a signal called the WOW signal. This telescope is the Big Ear Radio Telescope at Ohio State University's campus, and it was used very early on in SETI experiments to search for extraterrestrial life. And on August 15th of 1977, this telescope actually found something. What it found was a particularly loud signal coming from the direction of the constellation Sagittarius. The astronomer at the time, Jerry Emmon, noticed it in the recorded data. He circled it with his red pen, and he wrote, "Wow," because he could not believe what he just saw. Now let's take a look at that message. This, if this is aliens, then they're trying to tell us something. They're trying to tell us 6EQUJ5. People saw that and thought, oh, this is a message coming from outer space, coming from aliens, but what could it mean? And over those decades, no one was ever able to figure out what this stood for. Well, I'm happy to tell you that today is the first day that we finally got an answer to what the WOW signal stands for. And what it stands for is that 6 elegant quail were urging the Jackson 5 to, and then unfortunately that's where the message cuts off. Now, you may have a lot of questions. This is very interesting and groundbreaking stuff, such as, what does this actually mean? What did they actually need the Jackson 5 to do? They're not going to have all of them to talk to nowadays. And the real question is, do any of you even believe me? Because you shouldn't. Because obviously that is not a real message that was in the data. What the WOW message actually is just a measure of the intensity of the signal over 10-second observation windows that the radio telescope was taking. Those intensities were averaged. They were then compared against the background noise level with something called a signal-to-noise ratio. So how many times stronger is the signal they were getting over the background noise that they would have? So they would then assign a code to it based on what the signal-to-noise ratio was. 0 to 0.999 is just a blank space. 1 to 1.999 is 1, so on and so forth. You get to 10 to 10.999, you start going A, B, C, D, so on and so forth. So that part of the WOW message denotes a signal-to-noise ratio of 30, which is still pretty crazy that they found a signal that is 30 times stronger in that observation window than their background noise. So what actually was causing this if it wasn't aliens trying to talk to us? And, again, spoiler, it's almost certainly not aliens, but there have been some explanations put out. In fact, one very recently put out using archival Arecibo data that this WOW signal was likely caused by a very strong single source like a magnetar flare. Magnetar being a particularly strong neutron star. Pulsar is a very, very strong magnetic field. And it had a flare, an outburst, and that was just the one signal. We detected it at the Big Ear Radio Telescope, and this would also explain why the signal was never found again, because it was a one-off event. So what I want to focus on now is that while most of the telescope time that goes towards SETI experiments are in radio, the radio telescopes, there are ways that we can do searches for extraterrestrial life that does not involve radio telescopes. A couple that I want to highlight. First is the Europa Clipper mission. I want to highlight this because it's actually very recent. It was just launched about a month and a half ago, mid-October, and its goal is to study the icy moon Europa. It should get there in about 6 years, which actually is pretty fast to get all the way out to Jupiter. Because previous NASA experiments, such as the Galileo probes, were able to find that the moon Europa likely has an icy crust and potentially even a subsurface ocean. But that was all the data that it could get at the time. So what the Europa Clipper is going to do is try and study that in more detail, the characteristics of the ice shell, the subsurface ocean, and investigate sort of its potential for habitability. Not to say that there is life on Europa, but just the potential that it has the characteristics to host life there. And another thing that I quick want to highlight is that you can also use modern telescopes like the JWST, which is so strong and so powerful and great that it can not only detect exoplanets, but it can also take spectra of their atmosphere. That it can observe the light, that as it passes through the atmosphere of the planet, some light is absorbed by chemicals in the atmosphere, and some survives, makes it to JWST. We observed that, and we're able to figure out to some degree of certainty what chemicals could be making up that particular planet's atmosphere. That's very cool. It's been doing this for a lot of exoplanets that it discovers. One that I want to highlight in particular is this exoplanet K218b. So some of the chemicals that it finds here We have, let's see if this works. There's methane, there is carbon dioxide, things that may be indicative of a habitable planet. Again, not a sign of life, just the sign that it has some atmosphere that could habit or could like hold life there. The really interesting one though is this stuff on the end called dimethyl sulfide. Now dimethyl sulfide, there may be a couple ways that it could be created, but the primary formation channel of dimethyl sulfide, as far as we know it here on Earth, predominantly comes from phytoplankton in the ocean. But that is the gas that they emit. That's actually the molecule that gives the ocean sort of its like putrid ocean smell. And it's coming from phytoplankton. So again, there could be other ways that this chemical is made, but the fact that they were finding it in this atmosphere is very, very interesting because it leads to say that if there's not actual life on that planet, then there's got to be some other way that this can be made in quantities enough that we can detect. Again, they'll take more data and follow up on this, and you can stay tuned. Well, this is great and all. We're doing a lot of good work. Scientists are doing great work to search for extraterrestrial life out in the galaxy, out in the universe. But I think to end this talk, we really need to sort of take a step back and ask ourselves Jeff Goldblum's very important point in Jurassic Park. Is this actually a good idea to be contacting aliens? Because, well, we really have no idea what they're going to be like and how they're going to react to finding us. We might like to think that if we ever encountered aliens, they would come down, they'd give us a hug, they'd say, oh, so nice to meet you, they'll share some alien tech, they're going to give us a warp drive, all this wonderful stuff, and then they'll just leave in peace. But it is just as likely, if not even more likely, that we might see something more on the right, where they come down and they're not so happy to see us, and maybe they want our resources, or maybe they want something else, and then they kill all of us. And how are we supposed to know, right? This brings us to an interesting theory as to why we haven't seen alien civilizations yet, something called the dark forest hypothesis. The dark forest hypothesis is derived, the name is derived from Liu Cixin's book, The Dark Forest, which if you're familiar with the Three-Body Problem series, that is the sequel to the Three-Body Problem. What the dark forest hypothesis poses is that, sure, alien civilizations out there, they may be benevolent, they may be peaceful, but it really just takes one to be hostile, and that can be a major problem for the rest of us. So it's probably best to just stay silent to avoid alerting the one bad apple out there in the universe. So this hypothesis and similar theories are why a lot of scientists, including most notably Stephen Hawking, was very, very opposed to the idea of just sending out signals into outer space and seeing who responds to them. Because we could send out a message, and the very first thing that we hear back from aliens will be quiet, they'll hear you. So if I have you sufficiently scared now that we shouldn't be sending out any signals whatsoever, should not be contacting aliens, it is my duty to inform you that, too bad, so sad, we've already been doing it for about 50 years. We have sent, or scientists have sent, roughly a dozen encoded messages out various places into space towards nearby star systems. And this thing, the Arecibo message, which is pictured in the middle there, I'll go into detail that in the next slide, was sent to the globular cluster M13, about 24,000 light years. We've also sent some physical probes into interstellar space, stuff like the Pioneer probes or Voyager, but they're obviously not moving as fast as the radio signals. And as you can see, nobody's picked up yet. So this Arecibo message in particular, just want to highlight because, no worries. Anyways, the Arecibo message, just want to highlight in the last slide here, which was sent out to the globular cluster 24,000 light years away, has a lot of very interesting information that's encoded in it. Stuff like the numbers 1 through 10, a lot of information about the makeup of the human genome and DNA and the chemicals involved in it. Earth's population circa 1974 is encoded in there, a little drawing of that red drawing of like a human being, the average height of a human being. The solar system, which if you count the number of planets, there's 9. They included Pluto. Thank you. And at the very bottom, there is a graphic of the Arecibo dish, which was used to project the message. So if aliens are out there and they find this message and they're able to decode it, they're going to know a lot about us, and they're going to know what we're made of. So in summary, it's going to be an oversimplified summary of our talk. Some main questions that you may have. Are aliens out there? Probably. Again, whether you're a skeptic, a dreamer, a believer, they're probably out there somewhere. What do they look like? Anything, really. Again, we don't know. It could be the slime mold, it could be the little green men, or it could be anything else. Are they already here? Yeah, that's doubtful, in my opinion, that they are already here. Will we ever find them, though? We're trying. We can't really say anything to that extent right now, but scientists are trying their best. Should we contact them? Now, that is in the eyes of the beholder. That's up for debate, but also it might be too late. We've been sending out a lot of messages anyways. That is going to wrap up our talk for today, though. And thank you all for coming. Thank you all for supporting us over the last 10 years of CoffeeShop Astrophysics. We hope that we'll be able to see you again in 2025. Our first talk will be in February. You'll be able to check us out on our social media, our website, or our YouTube channel. Otherwise, we'll see you next time. It's going to be at the same time, same place, the same planet. Thank you very much.